Padma, can you see the screen?
Yes, sir.
Can you read anything?
No.
अच्छा, so did you not check the PDF that you uploaded, or is this a photo? क्या भेजा था आपने? This is a PDF.
Scan.
हाँ, scan what? PDF or scan photo?
PDF.
Look in your phone now. Is it like this only in your phone also?
So I'm using the laptop now. The phone is in the other room.
And the phone is in the other room. So you can't go to the other room and come back real fast.
Okay, I'll go.
Thank you. अच्छा, तब तक हफ्सा, I will just sorry हफ्सा, सारा, आपको हम बस थोड़ा बता देते हैं इसके बारे में कहा गया. Yeah, the atoms on white type. ठीक है? Can you see this?
Yes, sir.
So इसमें क्या है ना? First we will put atoms like this. We are having the same square close packing structure in the base layer. है ना? So we are taking that and we put atoms on atoms, and now we are putting atoms on white. First thing that we observed that if I have an atom on this if I have an atom on this white that is on top of these 4 black atoms, what is going to happen? These 4 black atoms, they will move a bit apart, है ना? Because we have kept something on top of them. So I'm just exaggerating how much they have moved, but still you can understand that they will move a bit apart, right? Yes or no?
Yes, sir.
Okay, so we have now placed this. Now you look here. We have placed this red atoms on the whites. And we have placed the red atoms on the white. Now, if you see here, if you see this red atom, okay, and wait a second.
I deleted the Fatima Ansari. I deleted the PDF, so I don't know.
You don't know. Achha. Maybe resend Hana afterwards.
How can I resend on the app?
अच्छा, निष्कर्ष सर को भेज दीजिएगा आप.
Okay, I can do that.
है ना? Okay.
Yeah.
So, Sarah, see, you have here the red atoms like this, okay, on the white, and you can see that there is a white created by these red atoms also, है ना?
Yes, sir.
है ना? And if I put atom just on top of those whites, then I will again be putting atom just above the black atoms, even though they are not touching each other. But अगर आप black atom में बैठ के देखिएगा ऊपर, so you will see another black atom. And then what I did, I took 4 of these black atoms from the base layer, from the A layer. Then I took 1 red atom that is on the white, made by those 4 black atoms, and on top of that we have again 4 black atoms. So this is why we get a unit cell which is body centered cubic. Okay, in body centered cubic you can see that corner atom, which is 8, the contribution of corner atom is 1/8, inside atom is 1, their contribution will be completely inside the atom, that is why it is equal to 1, and z is equal to 2. Relationship between A and R. So for relationship, we know that we have to use the atoms that touch each other. So atoms that those are touching each other are this corner atom, and then the red atom that is sitting on top of those 4 atoms, and then we have another black atom that is on the top of this red atom here. So if you draw a line, it will be like this, a body diagonal. So this body diagonal, all of these atoms are touching each other. All of these atoms are touching each other. Hence, we can see that if I take this atom from here to here, it is R. This distance is 2R, and this distance is R again. So A root 3, that is the length of body diagonal, is equal to 4R. Till here, everything is fine, yes or no?
Yes, sir.
Okay. Next thing is that this red atom, it is sitting on top of 4 black atoms, right?
Yes,
Anna?
sir.
So it is touching 4 atoms. Now, just above this red atom, there will be another 4 atoms, right?
Yes.
So these are the 4 atoms on top level. These are the 4 atoms in the down level layer, which are touched by this red atom here. Okay, so the coordination number is how much? Coordination number is 8. Now, this black atom is touching only the red atom. And in this unit cell, this black atom is only touching the red atom, right?
Yes.
Correct.
Sir.
And this black atom is present in 8 rooms, correct?
Yes. Sir.
And in 8 rooms, there will be 8 body center atom, and this black atom will be touching all of those body center atoms. So it is present in 8 rooms, and it is touching all the body center atoms of those 8 rooms. So for both of them, the red atom and the black atom, that means the body center atom and the corner atom, the coordination number is 8. Fine?
Yes. Sir.
Okay. So we have got Z, we have got A root 3 is equal to 4R, and then packing efficiency is something you have to do mathematically, since there is no chemistry here. Z is equal to 4 by 3 pi R cube. upon A cube, that is similar to the simple cubic one. And then you will see that when I put A root 3 is equal to 4R, that means A is equal to 4 root 3 by R, you will get to 68%. Then we did white percentage is equal to 32, and 100 minus packing efficiency, it will give you white percentage. Okay, and this was asked in NEET examination. That is another thing. Simple questions are also asked. Okay, so please, in chemistry, everything is important. And if they are asking you white percentage, that means each and every single point is important. After that, we did a little thing on BCC structure. What is the, we have been given the cell edge and we wanted to find the radius. Okay, each question बाद में कर लीजिएगा. And after this, we just define what is a crystal unit cell. ये बाद में I will come back to this. Okay, at the end of this chapter also I will come back to this. Now we are going to do. We have seen that in SCP, and we had HCP. So in SCP, we saw that there are two systems, simple cubic and BCC. So in simple cubic, the packing efficiency was 52.4%, and BCC it was 68%. And simple cubic, we put atoms on atom. In BCC, we were putting atoms on void. So here we can see that since simple cubic has a lower packing efficiency than BCC structure, so that we can say if I put atoms on atoms, it is giving me bad packing. So for HCP, what we are going to do, for HCP, we are going to put only atoms on void. Okay, everyone? Yes, both the Fatimas and Hafsa and Sarah.
Yes.
Okay, fine. So atoms on void, we put atoms on void. So for this, I will make the HCP lattice first of all. आपका इफ्तार टाइम कितने बजे है, सारा?
6:15.
6:15, no? So you will to leave after 6:15. So why not on 6:30 में? तो अभी जो क्लास है वो.
I'll have physics in Learnivio at that time.
6:30 में ही.
6:32.
And like how is the Akash? Like, is it online or is it offline?
Online.
Sorry?
Online.
Online. So you don't have to go anywhere. And your school, is it online or offline?
Right now, like today onwards, they've started like 3 hours. We'll have to go into it offline, and then we come home. We rest for 2 hours, and then we do 1 hour online.
This is first time offline in India, no?
For me, it's been offline since August last year.
Since August it has been offline.
Yeah.
अच्छा हाँ, बिहार में तो they have opened it. Okay, so this is the HCP lattice that we have. Okay, we have already seen this. Now, one thing that I observed when I look at this whole packing is that we have triangular voids, even though these are all spheres, these are no more circle right now. Okay, all of these are spheres, but still we will say that these are triangular voids only. Because if I join the midpoints of the atoms, it will be making a triangle. But I see that I have two types of triangular void. I have a triangular void which is upward facing, right? And I have a triangular void. So these are the triangular voids which are upward facing. Okay, so please listen very carefully. Don't try to write anything. And then we have some which are downward facing. Correct? Yes or no? Tell me. All of you can see that?
Yes, sir.
So we have HCP. And in HCP, I observed that there are two types of triangular voids in my packing. So the two types of triangular void that I have in my packing is a triangle whose apex is upward and a triangle whose apex is downward. And that means upward facing, downward facing. What I did, I just put a layer of atom on top of this void because I had to cover voids. So I will be putting atoms on top of this red one. Okay. So first of all, let me take one atom and put it on one of these red voids. Now, all of these are triangular void, but as soon as I placed an atom on top of this red void, this upward facing void, this triangular void got converted into tetrahedral void. Yes or no? Because we have 3 atoms in the base layer, and then I am putting one football on top of it, right? Yes or no?
Yes.
Can all of you see that? Okay.
Yes.
So similarly, what will happen? Similarly, if I take all of these atoms and then mark them red, and after that I will put it here. So all of these voids, they have been transformed from triangular void to which void? To tetrahedral void. Okay. Now we have only put one layer. Let me put another layer. So we have got now I have also added another layer, red wing. Yeah? So we have also added one more layer. Now here you can see two things happening. I want all of you to concentrate on these three black atoms. So these three black atoms. This black atom here, this black atom here, and this black atom here. And also, I want you to concentrate on this three red atoms. This red atom here, this red atom here, and this red atom here. Okay. So if you see, so red atoms are downward facing triangle, right? And the black atoms that were there, those were upward facing triangle. Can you see that? Yes or no?
Yes, sir.
The midpoint. So that, and there is a void here, which is this yellow one. Correct? Hannah? Yes or no? Tell me.
Yes, sir.
So this triangular void has been converted into tetrahedral void, and this yellow downward facing void, it has been converted into octahedral void. You remember now, this is also a octahedral void arrangement. Any doubt till here?
No, sir.
Sir, can you explain the tetrahedral void wala again?
Tetrahedral void. Okay, fine.
How it converted to tetrahedral void?
So you can see now this upward facing. ये दिख रहा है आपको? Tetrahedral void का structure. You know the tetrahedral void structure, right?
Yeah.
Three atoms, like in the floor, and then you put one atom on top of it. Right? 3 footballs on top of it. I'm putting another football. So you can see that we have 3 footballs here, and on top of it, I'm putting another football, red wala. See?
Okay.
Got it?
Yes, sir.
So as I put another layer on top of this upward facing, it became tetrahedral void. And if I then this yellow one, it became octahedral void. Now these tetrahedral voids, this red atoms. So in the red atom void, this tetrahedral void, it has 3 black atom and 1 red atom, right? Yes or no? You can see now.
Yes, sir.
So I can say that this is a tetrahedral void that is made by layer A. This tetrahedral void is made by layer A because most of the atoms here it is of layer A. Acha. Now I want you to look at these 3 red atoms. Look at these 3 red atoms here. Look at this red atom here. Okay, this red atom here. This red atom here. Okay, and there is a black atom just below these 3 red atoms, right?
Yes, sir.
So it you can see that it is also a tetrahedral void in which we have 3 atoms, and then on top of it we have 1 black atom. Correct? It is just oriented up in the opposite direction, but still it is a tetrahedral void. All of you can see that, yes or no? Both Fatima, Munir, and Ansari, and Hafsa, and Sarah.
Yes, sir.
Yes.
So now we can say that. And what is the specialty about this void that we have seen? That this void is made by 3 atoms of red and 1 atom of black. That means I can name this as tetrahedral void of layer B. इतना समझ में आया सबको? Yes or no? Tell me. Okay, fine. Now moving on. Now we will still be putting atoms on top of void. We'll be putting atoms on top of void. So first of all, let us see. We have 3 types of voids now. We have octahedral void. We have tetrahedral voids made by layer A. We have tetrahedral voids made by layer B. Let us try to put atom on top of tetrahedral void made by layer A. Okay. So when I am going to put atom on top of the tetrahedral void that is made by layer A, you can see that it will be not useful because I'll change the color. Will not be useful because so those red atoms now, so those red voids are the tetrahedral voids made by layer A. So if I am putting atoms, this green atom, then I am putting a green atom on top of red atom, right? Yes or no?
Yes, sir.
So this tetrahedral void, they have been already covered by the red atoms. That is why there is no use of putting another atom on top of red atom, right? So if I am putting any atom on top of this tetrahedral void made by layer A, it is not useful. Okay.
Sir, it's not congested. I cannot understand this.
हाँ, आप लिख रही हैं क्या?
नहीं.
नहीं, ठीक है, ध्यान से देखिए आप. This is the red atom. This is the red white, na?
Yes, sir.
Okay. So this red white is made up of which atoms? Tell me. 3 black atoms. And on top of that, we have put the red atom. Correct?
Yes, sir.
Achha, that means that white is already covered.
Yes, sir.
है ना? So if I am going to cover that white once again, will that be useful?
No.
No. If I want to put an atom on top of that white, then I am practically putting atom on top of the red atom only, right?
Yes, sir.
आपको समझ आया? Not useful.
Yeah.
Yeah, this is going to be get more congested. ठीक है? But you will understand. So this is clear ना? इसको ध्यान में रखिए, ठीक है? And please imagine that we have black layer of football, then I am keeping a red layer of football, ठीक है? On top of those whites. Start thinking like that. अच्छा. Now, what I will do? Now I will put atom on top of this B. Okay, tetrahedral white made by layer B. So shall those white? So यहाँ पे दिखा देते हैं. See, these are the whites that I'm talking about. Huh? These are the white that's made by 3 red atoms and 1 black atom. So I'm going to cover these. Will that be fine? Can you see that, Fatima Ansari?
Yes, sir.
Okay, fine. So let me take this and mark it green. So as you can see, as soon as I am putting a green atom on top of this, you can see that it is exactly above. It is exactly above the black atom, right? See?
Yeah.
Anna? So this layer is nothing but again the black layer. Got it?
Yes, sir.
Okay, fine. बाकी सबको आया समझ में? Yes or no?
Yes, sir.
So I will have A layer that is black. Then we will have the B layer. So A B layer will be making a tetrahedral white made by layer B, and that will be again covered by the A layer. And then the white will be covered by the B layer. Okay. So A layer से जो white बन रहा है, that is covered by B layer. Then B layer से जो white बन रहा है, that is covered by A layer. And then after that, A layer is making some white that is again covered by B layer. Okay, so this is the AB type structure. Okay, this is the AB type structure. Now, moving forward, and let us put atoms on top of the octahedral white, on top of the octahedral white. So if I put atoms on top of the octahedral white, that is the yellow white. Okay, so these are the yellow whites which are octahedral. Can you see that, Fatima? Yes or no?
Yes, sir.
Okay, fine. So let me actually now ये रेड एटम्स को और बना देते हैं. So there are a few more yellow whites that I will be covering. This white will be there, this white will be there. है ना? Fine. Now need some more atoms. Okay. So when I will place this here, so you can see that it is a complete new layer, है ना? So it is not on top of any other atom. Can you see that? Yes or no?
Yes, sir.
Yes, sir.
Fine. Who was this? Yes, sir. Okay. ठीक है? Fine, everyone.
Yes,
So I
sir.
place these atoms. Okay, I place these atoms. तो आपको और मार्क करके दिखा देते हैं. This yellow atom, concentrate here. Okay, this yellow atom, and this yellow atom. ठीक है? And just below that we have red atoms. वो red atom कौन से? We have this red atom. We have this red atom. ठीक है? Just focus on these. This red atom. So again, you can see yellow one is making a downward triangle, right? And the red one is making an upward triangle. Can you see that, all of you? Look
Yes.
at the bolded yellow one first, so, right? And then we have the red atoms like this. Now again, if I want, now this is again a new white. यहाँ पे है जो here. But again, you can see that if I'm going to cover this one, if I'm going to cover this white, this will be just exactly above the black atom. ये देखिए, right? Yes or no? Black atom यहाँ पे है ना आपका, देखिए. This is the black atom that you have in the first layer, right?
Yes, sir.
Okay. Concentrate. Okay, concentrate. And if I want to cover this void that is made by red and yellow, then I'm practically just putting atoms on top of the black atom only, above the black atom, not on top, but above the black atom. That is why, again, this is the A layer. Can you see that, all of you?
Yes.
Okay, so now please listen carefully. यहाँ पे देखिए आपको. So we had A layer, the black layer was there. Okay, so A layer, 3 atoms, and then we had 3 atoms of the B layer. They made an octahedral void, right? Both of these guys, they both made an octahedral void, and this void was covered by C layer. Okay, this void was covered by C layer atoms. Okay, now what happened? As you can see, पहले कौन से void थे? The void that was made by red and black and red. Then you can see that I made a void. It showed you a void that is made by the red atoms and the yellow atoms. All of you saw that, right? Yes or no? यहाँ पे जो दिखाया हमने अभी, है ना? Now this void was covered again by the A layer. Then again A and C will make a void which will be covered by which layer? Which will be covered by the B layer. Okay, and like this whole sequence will go on. Okay, so you will have ABC type if you cover the octahedral void. Is that clear? Yes or no? Please tell me.
Yes.
You're never going to understand this now because it is completely messed up. Okay, but please remember this flow. First of all, start with HCP, and we have 2 different type of triangular voids, an upward facing and a downward facing void. And after that, when I covered the upward facing triangular void, the upward facing triangular void converted into tetrahedral void, and there was a new type of void. And those tetrahedral void, I call them tetrahedral void made by layer A because 3 of those atoms were of layer A, that is black atoms. And I also saw that there are a new type of tetrahedral void that is made by the layer B because in that we have 3 atoms made by the red atoms, that is the second layer. And the yellow triangular voids that were downward facing, they converted into octahedral voids. Okay, now we have got 3 voids: tetrahedral void made by layer A, tetrahedral void made by layer B, and octahedral voids. Now you want to cover these voids, but essentially if I try to cover tetrahedral void of layer A that is already covered by the red atoms, it is not useful. We are essentially putting atoms on atoms, and we don't want to put atoms on atoms. That is why it is not useful. Then moving on to tetrahedral voids of layer B. So if I cover the tetrahedral void of layer B, essentially I am putting up a layer that is again the layer A. So that is why it is AB type. Now we come back to octahedral void. So we have the octahedral void that is made by 3 atoms of A and 3 atoms of B. And when I cover those void, I am getting a completely new layer, that is the C layer. Now I can see that there is a new void that has been created by the B layer and the C layer. And if I want to cover that layer, I am essentially putting a layer that is again the layer A. And now again, C and A will make a particular kind of octahedral void that will be covered by the B layer, and then again the C layer, the A layer, then B layer, then C layer. Okay, so this is the flow that you have to remember. Okay, so this is not very much useful. This guy is not very much useful. This flow is much useful. Okay, so please write this down. And what I would suggest is that repeat this. Anna, what you do, you repeat this whole exercise now yourself, each and every step. Okay, each and every step. Study. Write this down. Let me know when you are done. Acha, one thing. Wait. Just write a note here. Write a note here that number of tetrahedral void, it is equal to 2 times the number of octahedral voids. Okay, so here we have twice tetrahedral voids and octahedral voids. As you can see here, we have 2 tetrahedral voids and we have only 1 octahedral void. Right? So in both the packings, okay, in both packing, we will have how many? We will have twice tetrahedral void than octahedral void. Also, one more thing is that if octahedral void is equal to n, then tetrahedral void will be equal to how much? 2n. Okay, so please note till here, then let me know when you are done. Tell me guys if you're done. Okay, Fatima Munir is done, Hafsa is done. Okay. Just waiting for you, Sarah.
Done, sir.
Done. Okay. So first of all, we will study the ABC type. Okay, ABC type. Please remember this is ABC type, which has been made with a base layer of hexagonal close patching. Okay, it has been made from a base of hexagonal close patching in 2D. Okay. So first of all, we will have to look at the unit cell that we have. Okay, so for unit cell, I will be choosing some of the atoms. Okay, choosing some of the atoms. Now, all of you know now I can choose any set of atoms, right? I can choose any set of atoms, which I will repeat, and it will be giving me the whole packing. Okay. So from the A layer, I have the black atom, and then I have the red atoms. Then I will just flip this up and make it yellow. So we have the yellow atoms from the C layer. But please remember, whenever you are making unit cell, so you have to end with the layer that we started with. So again, I will have the A layer. So these are the atoms that I am taking to construct the unit cell. Okay. Now I will construct the unit cell. Right. This is the A layer. This is the B layer. This is the C layer, and this is the A layer. So I have a A layer atom here, one black atom. Just below it, I have a yellow atom. Just below it, I have a yellow atom, and then we have two yellow atoms here. Then we have a yellow atom here, three yellow atoms in this manner. And actually, wait a second. Let me do that. Maybe a bit closer. Yeah, I think this one now. And let me just copy this. Okay. And then we'll put a black atom here. Okay. Now we will construct some lines and try to make a unit cell. So I'll be joining these lines. Then I will be joining these two lines, these ones here, these ones here, these ones here. And I'll make somewhere. forgot two atoms. एक ये बीच वाला yellow I forgot, just yellow here, so it will be here. This yellow will be here, and I forgot this red one. So this red one will be somewhere in the center here. Okay. So here we have got a unit cell. So here we have a black atom. Here we have a black atom. Then we have two red atoms here. One red atom here first. Then we have two red atoms here. Then three red atoms are here. Okay. Then we have the yellow atoms. So three red yellow atoms here like this. And then two yellow atoms here and here. One yellow atom on top. And then we have again the black atom. So can you see that all of these atoms are placed in the face center? Yes or no? Can all of you see that? It is a face-centered cubic?
Yes, sir.
Okay. This is a face-centered cubic structure. This is a face-centered cubic structure. So I don't think you must be very much acquainted with this type of diagram of a cube. That is why I'm making a more conventional one. Okay. Now please see here. Okay, don't write now. Okay, don't write now. Please look here. So here we have this black atom here, and this black atom has three red atoms, which is on the cell edges. So you have this red atom here, this red atom is here, this red atom is here, and we have this red atom here. Can all of you see that these three red atoms? Yes or no? Please tell me. Can you see those red atoms? Yes or no? No. It is touching how many? This black atom is touching this red atom here, this red atom here. Can you see now?
Yes, sir.
Okay. Similarly, we have the red atom. Bataiye. Yes, tell me. Who is that, sir?
Sir, I said yes, sir.
Okay. Yes, sir. Sif sir aaya tha. Okay, fine. Then we have this red atoms which are on the face center here and here. Okay. And now what do we have? We have this red atom which is connected to, you can now look at this black atom which is connected to three yellow atoms here, here, and here. Okay, and we have one more red atom which is on top. Here and here. There's a red atom here, and we have yellow atoms on the ceiling, on this wall here, and on this wall here. Fine. So now you can see that this is a face-centered cubic structure. Okay, we have a face-centered cubic structure. This unit cell is face-centered cubic, and the packing is known as cubic close packing. This is abbreviated as FCC, and this is abbreviated as CCP. So FCC is the unit cell of CCP. So ABC time, but most of the time you will be referring this to as cubic close packing. Okay, so please draw this. Let me know when you're done. done, please let me know when you're done. Okay. One more line here, that FCC is the unit cell of CCP. FCC is unit cell of CCP. Sara, you have Akash on Saturday and Sunday only, no?
Tuesday, Thursday, Saturday, Sunday.
अच्छा Tuesday, Thursday, Saturday, Sunday. 11th 12th में तो 11th में शायद Saturday Sunday था ना सिर्फ शायद.
It was 3 days. I don't remember exactly.
Okay, okay. Done, guys? Tell me, please. Okay, Sarah is done. Fatima, Munir, Fatima Ansari, and Hafsa. Okay. Fine. Fatima, Munir, आपका हो गया? Keep your raised hand.
Yes.
Hand raised. अच्छा ठीक. So now let us first of all look at the Z. है ना? Let us look at the calculation of Z. Calculation of Z, that is the number of atoms inside the unit cell. So first of all, when we have to look the number of atoms inside the unit cell, how many types of atoms are there in the unit cell with respect to their position? How many types of atoms are there with respect to their position? So we have atoms in the corner. Yes or no, guys? Yes,
sir.
we have atoms on the corners. Okay, and we have atoms where do we have the other atoms? In the
inside.
Inside nahi hai na? No. Face center.
On the face.
Face center, right? We have atoms on the face center. Naam hi hai. Unit cell ka kya naam hai? Unit cell's name is face centered cubic. Okay, so how many corner atoms are there? Tell me, all of you. How many corner atoms are there?
8.
How many corner? 8. What is the contribution of each?
1 by 8.
1 by 8, and this will be equal to 1. How many face center atoms are there? How many face centers?
8.
How many? जोर से बोलिए.
6.
6. Okay, and what is the contribution of each? Sarah, do you know the contribution of each of these faces?
Yes.
What is the contribution?
1 by 2.
1 by 2. Contribution is 1 by 2. So this will be equal to 3, right? So we can write Z is equal to 1 plus 3, that is equal to 4. Any doubt till here? Any doubt till here, guys?
No, sir.
No doubt till here. Okay, fine. Moving on to the coordination number. Coordination number. So coordination number in which we have to see one atom is touching how many other atoms. One atom is touching how many other atoms. How many other atoms? Okay. So I want you to look at a particular atom here. So which atom should I take? We can show from the corner atom also. We can show from the face center atom also. Okay, fine. Now you tell me, this corner atom, it is touching these atoms, right? Yes or no? These face centers, right?
Yes, sir.
These face center atoms it is touching. So one corner atom is touching how many face center atoms in this unit cell?
2.
2 nahi, 3 na?
Not 3, sorry.
So the 2 walls here and here and one in the floor, correct?
Yes, sir.
Can all of you see that? So it is touching how many? In this unit cell it is touching 3. In this unit cell it is touching 3. Okay. Now you tell me if I have to construct a few things. Okay. Actually, यहाँ पे you will have to. How should I show you guys in a better way? So let me choose this one atom here. Okay, in this yellow one. Okay, so imagine what you can imagine, the space center atom. You can imagine that there is the atom hanging from the ceiling, just where your fan is. Okay, can all of you see that? Yes or no? Tell me. Can all of you see that in your room?
Sir, I don't have a fan.
You have a ceiling now.
Yeah, yes.
So you can imagine a center ना जहाँ पे fan हो सकता है. कहीं तो फिर fan देखा होगा आपने? Is Fatima Munir?
Yes.
This is weird way of flexing. Huh? What do you have? AC?
No, I didn't know what to look at. So I was like,
So you can imagine where to look, right? Fatima Munir?
yes, yes.
Okay, fine. Okay, so here you can see that there is a atom, and this atom will be touching these atoms here, right? Yes or no?
Yes, sir.
Correct. Now, also imagine that all the four walls, there are big atoms which are coming out from those four walls, right? Okay. Can you imagine that? Atoms coming out of the four walls also, as it is coming from the ceiling. Can all of you see that? Yes or no? Tell me. Atoms on the walls, right? On your
Yes,
four
sir.
walls. Okay. Now, those atoms will also be touched by the ceiling atom. Those are here, 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 and here. Okay. So now it is touching four atoms on the same layer, and it is touching four atoms of the down layer. Okay. Now, does anyone want me to prove? ये आपको समझ में नहीं आ रहा
Sir,
होगा.
how is the atoms on the side
हाँ,
wall
ठीक, ठीक. हाँ,
touching
हाँ, हाँ,
the ceiling?
हाँ, रुको तो. Okay. You tell me what is the distance? This distance is a root 2 by 2, right? Because it is half of the phase diagonal. Is that correct? Yes or no?
Yes.
ठीक है. So if I can prove that the distance between the ceiling face center and the wall face center is also a root 2 by 2, then it will be touching each other, right? Yes or no? If I can prove that this distance from here to here, this is also a root 2 by 2, then you will believe now that these two atoms are touching. No.
Yes, sir.
Huh? No, I think Fatima asked ना.
नहीं समझा sir.
नहीं समझा. अच्छा. This distance is a root 2 by 2. Okay. And if I prove that this distance is also a root 2 by 2, that means this black atom is touching this yellow atom and this yellow atom, both of these, right?
Yes, sir.
वही तो कह रहे हैं ना यहाँ पे. See, this yellow atom that is on the ceiling, it is touching the black atom, correct?
Yes, sir.
And its distance is a root 2 by 2, that you know.
Yeah.
You know it, right? And that you
Yes.
know. Now, if I prove that this green line is also a root 2 by 2, that means it is also touching the face center of the wall, right?
Yes, sir.
है ना? वो नहीं दिख रहा छोड़ दो आप, है ना? You believe in the, like, not believe in the mathematics, you just know that math is there and you just know that it is, yeah, it is true, and you don't even have to believe in this. Okay, so if I prove that this green line is a root 2 by 2, okay, so for doing that, what I need to do is I need to construct a line like this, and I want to construct a line like this. So this will make a right angle triangle, correct?
Yes, sir.
Okay, so this distance is what? A by 2, yes or no? Because this whole distance is a, this is the edge length only. Now we are covering this edge length from the middle of the face, but it is edge length only. Can you see that? Yes or no? Please tell me.
Yes, sir.
This also, this black line is also a by 2. This black line will also be a by 2. Correct?
Yes.
So we have the distance, that is the green distance. Distance square will be equal to a by 2 plus a by 2 whole square. This will be also whole square. So this will be equal to how much? This will be equal to a square by 4 plus a square by 4. This will be equal to 2a square by 4, right? Or we can also write this as 2a square by 4 hoga. This will be a by 2, right? A square by 2. A square plus a square, this will be equal to 2a square, and this is divided by 4. This will be a square by 4. Achha, did I do anything wrong? No, I did not do anything wrong. No? Yeah, I did not do anything wrong. Chali. So now you tell me this is a square by 2, right? No, a square by 4 होगा. Sorry. A square by 4 होगा. A square by 2 नहीं होगा. A square. This is a square by 4. This is also a square by 4. A by 2 whole square distance is equal to. Is there anything that I'm doing wrong? Wait a second. That distance is a root 2 by 2, na? A root 2 by 2. And this distance is a by 2. This distance is also a by 2. Want to find this distance out. A root 2 by 2. 2 a square and divided by 4. ठीक है, आ जाना चाहिए आंसर ना. चलिए. So let us see. So distance square is equal to a by 2 square plus a by 2 square. So this will be equal to a square by 2, a square by 4, sorry, plus this also will be equal to a square by 4. And this will be equal to distance square is equal to 2a square by 4, right? And that will give me distance square. Distance will be equal to 2a square by 4 whole root, right? So this is going to give me a square. See, a aa jayega, and from 2 I will be getting root 2, and by 4 I will be getting 2. Right? Yes or no? Tell me. The distance, see, Fatima?
Yes, sir.
Anna, so this green distance is also how much? A root 2 by 2?
Yes, sir.
Okay, this is also a root 2 by 2. Yeah. So if this is also a root 2 by 2, that means it is touching all of these walls, right? The atoms on the walls, correct?
Yes, sir.
So कितने atoms हो गए अभी तक? So we have this 4 atoms on the layer. On the same layer, we have 4 atoms, and then we have the wall atoms, which are now 4. That will be equal to 8, right? Yes or no? Correct.
Yes.
Now this is also touching. There will be a unit cell just above it, right? And there will be atoms on the walls here also. 4 atoms, correct? Right? Yes or no?
Yes.
Fatima. So now this yellow atom will be touching all of those 4 atoms that is on the wall. So we have 4 on the layer. There will be 4 atoms above and the 4 atoms on the below layer. So the coordination number will be equal to how much? 12. Coordination number is equal to 12. Okay. So the coordination number here is 12. Now moving on, the relationship between A and R. The relationship between A and R. Relation between A and R. So in relation, we have to see the atoms that are touching each other. So the atoms that are touching each other are the face diagonal atoms, right? So we have a black atom. So let's see. Okay, so you can see that these atoms are touching each other. अब किसी भी atoms को ले लीजिए, ये देखिए ये 3 atom touch कर रहे हैं, ये 3 atom touch कर रहे हैं, ये 3 atom touch कर रहे हैं. So all of these are, this is one of those phase diagonal, this is one of the phase diagonal, this is the one of those phase diagonal, right? So you can see that the phase diagonal atoms are touching each other. So let me make this all red here, and this line, this is the phase diagonal. So phase diagonal is a root 2. This is R, this is 2R, and this is R. So this is a root 2, which will be equal to 4R. Correct? Yes or no? बताइए.
Yes, sir.
Fourth is factoring efficiency. So factoring efficiency is equal to how much? Z, number of atoms, into 4 by 3 pi r cube. That is the volume occupied by the atoms divided by a cube. Divided by the A cube, that is the volume of unit cell. And we know that the relationship between A and R is A is equal to 4R by root 2. See, and into 100 will be there. So now you can write Z is equal to how much in this case? It is equal to 4 into pi into R cube divided by into 100 will be there. 3 into, for A cube I can write 4R by root 2 whole cube. Okay, so now can you simplify this? Yes or no? Please tell me.
Yes, sir.
Okay, fine. Chalo. So please simplify this. I think Sarah, you will also leave now. Acha, does anyone have to write this above parts? Calculation of Z vagara. So you can write it also. Okay. And I will be coming back in 20. I will be coming back in 15 minutes. Okay. So I will have my iftar. Azan is here now. I will have my iftar, pray my maghrib, and then come back. Okay. Fine. Then we will look at the whites. Is that fine? Yes or no? Please tell me. Can I leave?
Yes, sir.
What about others? Fatima, Munir, Fatima, Ansari, and Hafsa.
Yes, sir.
And please solve this. Okay. Please solve this.
Yes, sir.
Okay. Chalo. Fine. Coming back in 15 minutes. Okay. I think Sarah, you will not be there, na? ठीक है, तो आपको देखना पड़ जाएगा रिकॉर्डिंग थोड़ा थोड़ा हर क्लास का. ओके.
Okay, sir. I'll be back in 15 minutes.
अच्छा, ओके, फाइन, ग्रेट. ओके. Okay, so I am back, guys. Are you guys still calculating? I can't see any answers. Yes, Fatima Munir, Fatima Ansari, Hafsa. I don't know whether Sarah is back. Sarah, are you back?
Yes, sir.
I think you are back. So, guys, tell me. Oh, नहीं, Fatima, आपको बहुत ज़्यादा ही कम आ रहा है. It will not be like that. Okay. So, I'm talking about Fatima Ansari. Okay, that's very low. Fatima Munir, you're right. Hafsa, you're right. Okay, so let us calculate this. So 4 into 4 by pi r cube into, now this root 2 cube will be 2 root 2. Right? Root 2 into root 2 into root 2. Root 2 into root 2, 2, and root 2, that will be 2 root 2. So this 2 root 2 will come above because it is in the denominator of denominator. I have 2 root 2 here. Divided by 3 into 4 into 4 into 4, right? And then you will have r cube into 100. So you can cancel this 4, this 4, this 4, and this 4. And what else you can cancel? You can also cancel this 2 by this 4 and right here 2. You can also cancel this r cube and this r cube. So basically what you will be remaining with is pi, and there is root 2 is there. So your root 2 can also be cancelled by this 2. You'll get root 2 here because root 2 times root 2 is equal to 2. So pi is there in the numerator, and the denominator we have this 3 and this root 2 into 100. So if you do 3.14 divided by 3 into, what is the value of root 2? What is the value of root 2, guys? Can anyone tell me? What's the value of root 2?
1.1, 1.4.
1.414 into 100. Okay, so if you will solve this, this will come around 74%. Okay, so please write this down. 74%. Then other few things that you have to write is packing fraction, it is equal to 0.74. Then there is void percentage, which will be equal to 100 minus 74, which will be equal to 26%. Okay, so you will write till here, but please listen, don't write now. यहाँ से तो आपको लिखना है. Let us discuss one more thing, that is the void. So voids in FCC. Please remember, we are talking about not the packing, we are talking about the unit cell. Please remember, we are talking about the unit cell. Okay, so we'll have two voids here. We will have octahedral voids. Which is equal to n. Okay, and what is n here? N is the number of atoms. Okay, n is always the number of atoms. So in FCC unit cell, how many atoms are there? Tell me, what is the Z for FCC? What is the Z for FCC, guys?
3.
नहीं 4 ना, कैसे गलत लिख लिया क्या आपने? Z is equal to 3 plus 1 4. So number है ना, so number of octahedral voids will be equal to 4, and number of tetrahedral voids will be equal to 2n, and this will be equal to 2 into 4, which is equal to 8. Okay, so you just need to copy these few lines. Please copy it. Fatma Munir is done. Waiting for Fatma Ansari, Hafsa, and Sarah. If somebody asks you, tell me the answer for this. What is the total number of voids in FCC unit cell? So what is the total number of voids? Tell me.
12.
Yeah, correct. So the total number of whites will be equal to octahedral whites plus tetrahedral whites, which will be equal to n plus 2n, where n is the number of atoms, which will be equal to 3 into n, that is 12. 4 3s are 12. Achha, but if I have a question like this, a solid forms CCP, that is cubic close packing. This is cubic close packing. Then what is the total number of, what is the total number of voids in 0.5 mole of it? Okay, 0.5 mole of it. So can you see the difference between these two questions? Here they are asking about a unit cell, and here they are asking about a complete packing. Okay, here they are asking about a complete packing. So please listen. So when we have CCP, that is cubic close packing, it has two different type of voids. We have octahedral voids and we have tetrahedral voids, right? And octahedral void is how much? It is equal to n, and tetrahedral void is equal to how much? 2n. And what is the n here? N is the number of atoms. Here also 2 into number of atoms. Okay, so there is a solid which forms CCP. Okay, what is the total number of voids in 0.5 mole of it? So how much solid is there? How many atoms of solid is there? Tell me by the question, how many atoms of solid is there which is making the whole packing? How many atoms are there? Look at this word here, 0.5 mole of it. What is it? It is the solid, na? Yes or no? Yes, Sarah,
Yes,
Fatima, Hafsa. It is the solid. So how many? So what is the atom? What is the number of atom of solid? It is 0.5 mole. Correct? Right. This is the number of atoms which is making the packing. Yes or no?
Yes, sir.
Okay. So you understand the difference between packing and unit cell? All of you? अच्छा, कुछ हाई नहीं, आपको जवाब ही नहीं आता. What happened? हाँ. अच्छा, tell me. If I have one unit cell, then there are 4 atoms. Correct?
Yes.
If I have 2 unit cell, then there will be how many atoms?
8.
8 atoms. So in one unit cell, you will have 12 voids. Yes or no? In one unit cell, you will have 12 voids. Correct?
Yes, sir.
In the other unit cell, you will also have 12 voids, right?
Yes.
Yes.
So can you see that if you have a large number of atoms, now you have 8 atoms, and 8 atoms is making how many unit cell? 2 unit cell, and that is why the number of void is also increasing. So it depends on the number of atoms. So when you have a unit cell, then you are looking at the atoms just inside the unit cell. But if you have the packing, then you have to look at the whole packing. So in the packing, we have how many atoms? 0.5 more. That means 0.5 into 6, 0.22 into 10 to the power 23 atoms are there. So number of octahedral void will be equal to number of atoms, which will be equal to 0.5 into 6.022 into 10 to the power 23 octahedral voids will be there, and number of tetrahedral voids will be 2 into 0.5 into 6.022 into 10 to the power 23. Are these 2 points clear? Yes or no? Please tell me. So the total number of void will be equal to how much? Total voids equal to 0.5 Na octahedral plus 1 Na of tetrahedral void, which will be equal to 1.5 into 6.022 into 10 to the power 23. Total voids will be there. Okay, so please write this down. Let me know when you're done.
Sir, will it be 1.5 into 6.022 into 10 raised to 3 or 10 raised to 23?
My bad. 23. Done now, all of you?
Yes.
Okay. So this is it for the FCC lattice. Next time we will be looking at this AB type. Okay. So tomorrow we'll be looking at AB types, and hopefully this whole unit cell and packing thing will be done. We'll be looking at a lot of questions from now on. So tomorrow you will be starting with formula based compounds formula. What is a formula of compound? Those type of questions. And in the next class, we'll be looking at the density questions. Okay. So after this class, you'll be having a lot of questions. And until here, it was conceptual theory part. But in the next class, we'll be having numericals. Chalo, fine.